we are solving MCQs of alkyl halide. Alkyl halide. This is part 6. Okay, this is part 6. So let us move to the questions. Okay. So now, okay. Which one of the following is responsible? Which one of the following is responsible for depletion of ozone layer? Okay, so option number A is water, no. Carbon dioxide. C number chlorofluorocarbon. This is the most important, this one. And methane, not really. So this one, chlorofluorocarbon, is the main cause of what? Depletion of ozone layer. Okay, so question number 2. Okay, let us, and okay, look over here. An alkyl halide produces single alkene on a reaction with sodium ethoxide and ethanol. Okay, the alkene further undergoes what? Hydrogenation to yield 2-methyl butane. Okay, 2-methyl butane. Now identify the alkyl chloride amongst the following. So it is said to identify the alkyl chloride. Okay, so let us come here. Look here, suppose there is Rx, right? Which on, suppose this is A, which on there is sodium ethoxide, right? There is sodium ethoxide. On the presence of ethanol, this produced alkene over here. This is dehydrohalogenation reaction, which on hydrogenation, this produced what? Let us say 2-methyl butane, that is your CS3, and this is your CH2CH3, right? So this is the only one product that is formed, right? So can you think that where should the double bond be? Okay, if there was double bond in middle, then there would have been 2 different products, right? If there have been the bromide, okay, think once more here. Suppose, come here, suppose this is the CS3C, then CH3, suppose here it was Br, and suppose this is CH2 CH3, and you do dehydrohalogenation reaction, then there would be two different products over here, right? And here it is said single alkene, so bromine was not here. Are you getting it? If the bromine was here, then also two product would have been formed. Suppose, let us think like this. This is CS3, CH, CH3, and this is your CH, and there is Br, and this is your CS3. Then also two product would have been formed, because this is alpha beta elimination reaction. Alpha beta means what? This is alpha carbon, this is your beta carbon, and this is again your beta carbon, right? So hydrogen would have been released from the beta carbon, and bromine would have been released from the alpha carbon, right? So two products, one from one hydrogen. If we remove this hydrogen, one product will be formed, and if we remove this hydrogen, second product will be formed. So two product is possible from here, right? Now let us come to the third option that we are thinking of, that is your C. This is your CS, this is your CS3, this is your CS2, this is your CS2, this is your Br. So let us come here. This is alpha carbon, and there is only one beta carbon, right? So only one product will be formed from here. Only one product will be formed. So probably this will be your compound. Probably this is your compound, and it is said chloride, right? So let us put here, in place of bromine, let us put chlorine. So what will be the name of this one? This is your okay, 2, okay, let's say it is 1, and this is your 3 position, so it is 1 chloro 3 methyl butane, right? So this would be the answer, right? This would be the answer. Are you getting it? That's it. Okay. Or you could have said the chlorine is, what if the chlorine was here? So okay, once more, let us revise. What was the product to us? Product to us is this one, right? Product to it is this one. So option, okay, you can think this way. Okay, so it is simply terminal alkyne, terminal, this one primary carbon. From primary carbon, the hydrogen would have been released, and there would have been double bond, right? There would have been double bond. Okay, the next question that we are going to study now, the reaction on an alkyl halide. Okay, we have done this. Now next question, a compound and that will form offensive smell when heated with chloroform and alcoholic KOH, and this is option number that is just given to like us like this, C2H5 whole 2 NH. This is your secondary amine. This is your secondary amine, right? Now option number B is CS3 whole 3N. This is your tertiary amine. Option number C, that is your C2H5 and H2. This is your primary amine. and option number D, that is your CS3CN. This is nothing. So we know that this chloroform and KOH with the help of primary amine plus CSCl3 plus this is your KOH. So this will react to give what? R and C, which is your isocyanide. Okay, offensive, it has offensive smell or bad smell, you can say. So with primary amine, right, carbyl amine reaction is possible with, this is called carbyl amine reaction, right, carbyl amine reaction. So this is primary amine. So the next question that we are going to do is, okay, question is like on warming chloroform with what? AZ dust. What will this give? We have already seen previously, this will give ethine or alkyne. Okay, next question. So isopropyl chloride undergoes hydrolysis by isopropyl chloride undergoes hydrolysis by A number SN1 mechanism, B number SN2 mechanism, both D number known. So it will undergo by both. Okay, it will undergo by both, possible. Okay, so next question. Which of the following have maximum dipole moment? Which of the following has maximum dipole moment, right? So option number A is CS3Cl, option number B is CS3Br, option number C is CS3I, and option number D is CS3. What is left now? CS3F. Okay. So remember, dipole moment is actually net multiplication of net charge, right? Net charge into distance, right? Distance between what? C and X. So look here, in case of electronegativity, right? Look here, the net charge will be more, right? More in case of D. Okay, into CCl distance is very less because F is very much electronegative, CF. Okay, so in case of chlorine, though there is no much net charge as compared to fluorine, but CCl distance is more here. So this makes mu Cl greater than mu F. That is your dipole moment of chlorine is more than dipole moment of, that is your fluorine. That is your methyl fluoride, right? Fluoromethane. You can say fluoromethane and chloromethane. Chloromethane has more dipole moment than fluoromethane. Then follows the order, that is your mu of this CS3Br, then mu of iodine, right? This is the order. So this will have more dipole moment. CS3Cl has more dipole moment than CS3F, which has more dipole moment than Br. CH3Br, which has more dipole moment than CH3I. Okay. Now let us come to the next question. Okay, and the question is, which of the following is most reactive toward nucleophilic substitution reaction? Which of the following is most reactive toward what? Nucleophilic substitution reaction. Option number A is C6H5Cl. Option number B is CH2 double bond CH2Cl. Option number C is ClCH2 CH double bond CH2, and option number D is your CH3 CH double bond CHCl. So we have already seen that. We have to check for the what stability of the carbocation, right? This is less stable. This is phenyl carbocation. This is also very much less stable. This one is allyl carbocation, and this is your stable carbocation because there is positive charge, then one single one, then double bond, alternate double bond is present. So what will happen? This positive charge will delocalize from here, and this one this will form, look here, this one, look here. Now this carbocation is actually not mobile, right, from here, because double bond and positive charge, there is no alternate double bond right here. Are you getting it? So this is the most stable carbocation. So option number C is the correct answer. So next question that we are going to discuss is the reactivity of alkyl halide for dehydrohalogenation is. The reactivity of alkyl halide for dehydrohalogenation reaction is. Okay, so option number A is RF, RCl, RBr, RI. Option number B is RI, RBr, RCl, F. Option number C is RI, RCl, RBr, RF. Option number D is RF, RI, RCl, RBr. Okay, so first of all you have to understand the leaving group tendency, right? So I minus is better leaving group than Br minus, then Cl minus, then F minus, right? So look this one, R, Br, Cl and F. That's it. Option number B. So next question that we are going to discuss now is okay, a set of compounds in which reactivity of halogen atom is in ascending order. Okay, a set of compounds in which reactivity of what halogen is in ascending order, right? So option number A is chloroethane, chloro. Option number B is chlorobenzene, chlorobenzene. Option number C is vinyl chloride, vinyl chloride. Okay, so option number B is your chlorobenzene, chlorobenzene. Okay, it is like this. This is chlorobenzene. This is your vinyl chloride, and this is your chloroethane. Option number C is vinyl chloride, vinyl chloride, then chlorobenzene, chlorobenzene, and then chloroethane. Option number D is vinyl chloride, vinyl ascending order. Okay, ascending order. Okay, so this is your chloroethane, vinyl chloride, then okay, ascending order. So I have done something wrong over here. Let's put comma, not greater than, so that we can judge. Okay, vinyl chloride, and then this is your chlorobenzene. Okay, so let us decide first. In chlorobenzene, look here, this is your chlorobenzene. When chlorine is removed from here, the positive charge is directly over here, right? So this will be forming positive charge over here. The next is vinyl chloride, means CS2 double bond CS2, positive charge over here. Next is your uh, chlorobenzene, right? So chloroethane. So this is your, so look over here. Actually, benzene itself provide minus I effect, right? Benzene itself provide minus I effect more than double bond, are you getting it? So look here, this will make it more positive, over here, and this charge is not delocalized. This will form positive over here, but a bit less than the benzene, and here it will be giving plus I effect, so it will be making more positive plus I effect. That is your electron is giving there to neutralize this positive charge over here. Are you getting it? CS3 shows plus I effect, right? And it will try to neutralize this positive charge over here. So this is a bit more stable, right? A bit more stable. So from ascending order, if you are thinking, then chlorobenzene is least stable, then vinyl chloride, then chloroethane. So option number B is the correct answer. Are you getting it? Next that we are going to do, okay, which of the following halide is, which of the following most reactive halide toward SN1 reaction. Most reactive halide toward SN1 reaction. Okay, so uh, given to us is, let us see here, option number A is secondary butyl, butyl halide. B is n-butyl halide. C is allyl halide, and D is your tert butyl halide. So allyl halide would be the answer. We have already seen this. So the next, okay, the order of reactivity of alkyl halide toward elimination reaction. The order of reactivity of alkyl halide toward elimination reaction. A number, third degree greater than second degree greater than 1 degree, first degree, that is first degree greater than second degree greater than third degree, second degree greater than 1 degree, third degree not. So the option is this one. Okay, elimination also follows the same like our SN2, right? Third degree, second degree, then first degree. Okay, okay, so next question that we are going to see is, now Mg reacts with RBr, okay, based in to form Grignard reagent. Actually, first is C6H5OCH3. Option number B is C6H5 and CH3CH3. Option number C is C6H5, sorry, this is C2H5OC2H5, and D equally in all. Actually, this reacts with this in case of all of this. Okay, reacts, but better, it reacts better in this. Okay, because in this case A and B, there is benzene ring and there is electron over this O, and nitrogen as well. There is electron which gets delocalized into the benzene ring, which gets delocalized into the benzene ring, and there is less in A and B case, there will be less electron now required for coordination, right? Less electron actually required for what? Coordination. But here the electron won't be delocalized, right? Electron won't be delocalized. Electron won't be delocalized over here. Delocalized over here, and it is available for what? Coordination. Available for coordination. So it reacts best in this medium. Okay, are you getting it? So there are 5 electrons over here actually. So there are 3 bonds, so 2 electrons left. Okay, Next. Okay, Grignard reagent is not prepared in the aqueous medium. This is said that Grignard reagent is not prepared in aqueous medium, right? Why? But prepared in ether medium. But prepared in what? Which medium? Ether medium. Tell me why. So the option number A is reagent RMZX reacts with water. Option number B says reagent becomes inactive in water. RMZX becomes inactive in water. Option number C says insoluble in water, insoluble in water. And option number D says that the reagent is highly reactive in ether. Highly reactive in ether. So let us just this one. R mgx when reacted with water, right? This is positive, this part is negative, right? This H will attack over here and OH minus will attack over here to form RH plus mgOHx, right? So water actually reacts with the Grignard reagent to form alkane. It is because of this the Grignard reagent is not prepared in the aqueous medium. So let us move to the next question. Okay, and that is your dipole moment. In this we have already done. Okay, this is very important question. You can remember this. This is actually VVVI question that is very important. Okay, at a higher temperature iodoform reaction is given by option number A is CS3 C double bond O CS3, right? Then this is your that is your CS3 C double bond O C6H5. Option number C, that is your CS3 C double bond O C2H5. Then option number D, that is your C6H5 C double bond O C. Okay, 3. Okay, so remember once. So at the higher temperature hydrolysis, okay, at higher temperature, at higher temperature, if we do hydrolysis, so the bond breaks. So the bond breaks in this manner. So this will give you what? This will give you, look here from this side, this is giving you CS3OH. Look from this bond will be breaking, so this will be giving you C6H5OH, right? Look here, this will be giving C25S5OH, and this one, look here, this will be giving CS3OH. Look here. So iodoform test is given by CS3 C double bond O group or CH3 CHOH, this group, right? So we know if we make this structure over here, this is giving us CH3 CHOH, right? So look here, this will give you this one will give you iodoform test, iodoform test, right? This will give you iodoform test. This won't give you iodoform test. This won't give you iodoform test. This will also not be giving you iodoform test. Only this one will be giving you iodoform. This is also not giving you iodoform test, right? So this C number is giving you iodoform test. This is very important question. Okay. So next question that we'll be discussing over here is question is, Wood's reaction, okay, involves the reduction of alkyl halide with, so option number A is actually Hi, option number B is ZnHCl, option number C is Zn in an inert solvent, okay, in an inert solvent, and option number D is your Na in ether. So this is right answer. Okay, this is like Rx when reacted with Na in the presence of ether, dry ether actually. This will give you Rr plus 2NaX. Remember, you can only use dry ether over here, not the wet ether, because this will produce alcohol instead of giving you alkane. This will produce alcohol. Okay, so remember this one. This is very important. So we have done till now this much. The rest we'll be doing in another part. Thank you.